Well, good morning.
Morning, Jam.
How you doing? Well, we'll see how many humans we get. Ari and I didn't send out an agenda, which is it's not typical. We usually do. Um, could be a short call.
Okay. Doesn't this also fit into the CDI initiatives, or is it totally different? Are you
Very similar. Yeah, we're kind of I generally give like pass downs in the CDI meetings for everything that's going on in OCP because it's all tied together.
eventually will you have a standard, or it's just going to be the white papers which you have already authored?
Yeah, there'll be standards. Well, for this work group, we're talking. We are trying to work on a white paper before August or before July.
Okay.
Um, hopefully, hopefully Ari joins. We'll give it a few minutes here.
Okay.
Good morning.
Good morning.
So, well, it could be a short meeting here, guys. But show you what Ari and I were working on. Um, Hopefully this is you guys, we hope. Somebody else poking around the work group.
That's me, probably. We get off, make sure.
Yeah, were either of you guys on the monthly call?
I missed yesterday's call.
Yeah, the monthly one was like, I think it was last week.
I-
Yeah, so Pankaj came in and gave he was like the director of GHE protocol, and kind of he gave an update on what's going on in the standards. It is on the, gosh, can never find anything. But if you go to sustainability wiki, which is on sustainability wiki, there's recording the meeting here. So if you're interested, let's see.
Thank
But yeah, the big news was, I mean, that it's going to be a while, right? Like the new greenhouse gas reporting standard is not going to be until 2026. They have received a ton of comments, and circularity was in the set of comments they have received of stuff that they should potentially cover in this next spec. The big addition is this new market-based accounting, which I think if I'm reading into it is really around, carbon credits and carbon offsets and that world. And then there's updates to scope 2 and updates to scope 3 guidance. And it sounds like there may be in that scope 3 guidance, that would maybe be where this circularity stuff lives. But they emphasize that certainly like what they want to do right now is collect all the stakeholder input, because all the work groups are going to kick off for the actual, and I mean, these are like, it sounds like, very, very well, obviously it's like an international major, high impact spec to all the stakeholders involved. So they definitely, it's like high touch, and quite a bit of resources spent on this. So yeah, they'd like to collect all the feedback, soon. So our idea was to release this white paper on carbon accounting for circularity with the different approaches and models we came up with, and potentially influence, because ideally we don't want to be doing something that's not consistent with the greenhouse gas reporting standard, but we also heard that it's not going to be for a few more years before they address any of the circularity stuff. So we should at least describe how we think it should work, and then see how that fits into the overall strategy. So Stefan, how you doing?
Good morning, doing good. How about yourself?
Good. I know I feel bad I didn't send out the reminder. So we're a little light on attendance here, but oh, good. We have Shruti, which is good.
Hi, folks.
Good morning.
Morning.
Good morning.
I was just recapping the Pankaj's presentation.
Mm-hmm.
So yeah, I think the big thing, he said they're open for feedback. We should be absolutely looking to provide material of how we would like to see things done. Didn't sound like there's some kind of official format, but I think from the last work group we had decided we wanted to kind of do this paper. So I have had AI get us started here this morning. So yeah, Shruti, looking for feedback here. I think this was kind of what our idea was, just basically the core idea is circularity is a key strategy in sustainability, and we want to, and the current accounting methods don't properly account for circularity and don't incentivize circularity. And so we want to, basically figure out if there are ways that we can amortize the embodied carbon over the two uses, or extended use or reuse, and how do we account for that. When Pankaj was talking, I don't think the market-based accounting was going to cover any of the circularity stuff. I think it sounded like any of that would go into the updated scope 3 standard. Is that kind of what you heard, or?
I'm not quite sure where he said it would be covered, but I know he said that they have gotten feedback on that. So that is one topic that they will be covering in, one of the 3 updates that they are releasing.
Yeah.
Yeah, and on that note, yeah, so looks like they, for some time, they keep like a form kind of thing open on their site, but that process is actually closed. However, they sort of asked us that if OCP particularly wants to give some feedback, we can collate it and sort of like a document, send it to them, and the person who was coordinating with me will just help make sure it reaches the their, what do you call, their work group folks that are working on it.
Fantastic. The ones that also I was thinking of is, so does this capture, I think the big one was the amortization models, for, between, this is just AIs. I took our meeting notes and came up with this, but we'll definitely need some more time refining the outline here. But the current models where we just say we want to amortize over extended use period or 2 users. Second model is, kind of what we do today, which is you do a new life cycle assessment of the recertified product, and the new recertified product has no embodied carbon or low embodied carbon because it all got taken by the first use.
Mhm.
And then I think that the third one is, I guess we haven't talked about this, like take back programs, or how do you do it if it's like a lease model? Do you know how that works today with, like, if you're leasing equipment for the data center? You definitely don't take, or I guess I don't know. Do you not take the embodied carbon when you're like doing say, for instance, the 3-year lease?
I don't think there's a norm, right? Like folks are doing what is convenient,
Yeah.
which is probably not taking the embodied carbon in case of lease.
Yeah.
Yeah, I'm pretty sure that's the same thing.
So
I've heard it before too. It's the same thing as if it's leased, or they have a setback, take back program. They just say, well, that's being handled by that take back company. So
right. So Jim, can you list all of these cases so we know that, one by one, when we start talking about the solutions that you were suggesting, we'll know that we went over all the cases.
I have one other question on circularity as well. The amortization right now is only over a time model, is that correct?
That's what we were thinking, right? Which I guess, just tell us, what you're thinking. We had the two use cases we had were, amortization model spread out embodied carbon to report over extended use, which this is tricky because right now, right, if a company uses something for 10 years instead of 5 years, they're not getting any benefit because they took the scope 3 upfront when they bought the embodied carbon. But obviously it's better to run the things for longer, at some point, so
Yeah, this is the problem. So go back to the life of an SSD, right? And how, for example, this is defined within the JEDEC standards, right? There's a use model, right? A workload model assumption that will then get you kind of like a tread life, right, of a tire alike, basically calculation, right? So I think if you really want to have a fully transparent association, or of the embedded carbon, you would have to actually associate it to how the product is used. Because if an SSD, let's say, sits for 2 years, right, just and with little to no activity, you may have significant life on its left, right? And so from that perspective, time alone may not be a sufficient representation of how this should be, allocated within a circularity consideration.
yeah, or maybe this first one is really just best practices around, self-reporting, or like if you're going to use a device for 10 years or 7 years instead of 5, you should be reporting, hey, this is for this use case, this is our life cycle assessment, this is our embodied carbon impact per year per terabyte, or per core, or whatever the unit of account. I know we have another work group that Shruti is running, that we're trying to talk about the figuring out what the useful unit of work is for some of these segments, so we can basically have some comparability. But I think where we landed with that was that this is an incredibly challenging problem as well, and it's
Yeah, I mean, we are still able to formulate that on a device level. But from what I understood, I think Stephen's question is not resolved by that. Like what we are doing there is just trying to show carbon per unit ability of the device, right? But what he's pointing out is even during amortization, you have to take how much ability of the device has been utilized,
Exactly.
has been reduced, either utilized or just by sitting around. I don't know, some kind of devices might actually lose life because of sitting around. So
and by the way, that applies. Yeah, that applies also when you look into the future of disk drives, right? You need to think about HAMR. You will have also limited write and limited read cyclicality, right? That you will have to account for. And I'm afraid that even a assessment on a workload model may be challenged because in today's virtualized world, right, you may not be able to tell, right, what ultimate workload a particular, subsystem may experience, right? If that's the other problem there as well. So you would have to think about if you can have self-reporting, right, from at the subsystem level of activity, right, that the device has performed over time.
Yeah. Yeah, and I think these bring up a bunch of good questions about what we should recommend for OCP members to do, and then what we should recommend to the greenhouse gas reporting standard to update to include, and then maybe some guidelines and frameworks and templates that other folks can use to do this. Okay, so I think our first model is. Oh yeah, go ahead.
So sorry, if I can, for just a minute, dig into that question that Stefan was raising. Stefan, like when you were sort of imagining this scenario, what were you thinking for devices that actually would lose life just by sitting around? So maybe, it's a hard drive. I have not done too many writes on it, but maybe over time it's, it's more probable to mechanically fail.
Yes, exactly. That's why I'm saying you have to account for time and usage. It's exactly as this is a correct point that some devices, even if they're sitting there, right, with the fluids, right, or mechanical considerations that are aging, that's the other piece as well.
Yeah, the flash and hard drive example is fairly easy because, well, most of the studies have shown that the hard drive wear increases, the probability of failure and reliability decreases with its use, and so it just depends on the first use environment. Flash is fairly easy to forecast as far as like the endurance, because it's already built into all the drive reporting as far as like percent used. But this is a great example. I will just say I won't name any names for hyperscalers, but some of the pilots that I've seen for Circularity had like, for the SSD clusters that were in use for 5 to 6 years, they still had like 87% use left on the drives. So it's like, yeah, not only is it like just atrocious to be all destroying all these things because of the embodied carbon from the flash, from the manufacturing, but also just the fact that they have useful life left. But
exactly, yeah. And what they measure in these trials, right, is what you ultimately will then have to use, right, that's what I was suggesting for the self-reporting. I think the data exists. The manufacturer have the data or capture the data. They do that anyways for warranty, right, considerations. So it's just a question on how you basically have it flow into this calculation here.
So JM, part of the accounting, you're saying report all this? I mean, if we don't, that is, if whatever device doesn't, I know from a storage perspective, flash perspective, you can get that information, but is that what you're asking of this, the accounting, carbon accounting? Like, let's be able to do A, B, and C?
I'll just kind of rewind just so we're kind of on the same page as far as major problems. Okay, so most SSD vendors, and I'll say there's other ICT vendors, like as far as like server vendors and memory, don't have very good life cycle assessments today that are publicly available, that has public data on their website. Now, I've talked to a lot of these NAND manufacturers privately, and they said, "Oh yeah, we have plenty of data. We obviously know how much power our fab takes, and we know if, the renewable energy versus traditional fossil fuel energy mix, for the fabs." And so they, the problem is that like the embodied carbon from manufacturing stuff like memory and flash is very high.
Yeah.
So our idea one is that, and this is just a separate problem, which is just vendors need to properly report, do proper life cycle assessments to properly report the embodied carbon of their device. Like how much did it actually take to manufacture that thing? Once we have that number, then we can come up with, okay, well, instead of just using it for 3 years and destroying it, you should be using it for a longer period of time. This is just circularity strategy. And then this third part is like, how do we account for that such that, right now, scope 3 is a major, it's like, for instance, Meta, 99% of their carbon footprint is scope 3, in their greenhouse gas reporting. And most of that comes from, use, not these use of sold goods, but the embodied carbon from, stuff that they buy from data center equipment. And this makes sense, right? Because the hyperscalers have their data centers on renewable energy, but their suppliers, are not using a bunch of renewable energy.
Right.
And so, now their emissions have shifted from scope 1 to scope 2 to now almost all scope 3. And so what they're trying to solve, the hyperscalers are trying to solve, is how do we reduce our scope 3 number? Because that's now we want to get to net zero, and scope 3 is a big part of that. And so our whole idea with this work group is is there a way that circularity can help? And in today's greenhouse gas reporting standards, circularity doesn't count per se. Like you don't get to take carbon off your books by selling it to a separate second user. But we're suggesting that maybe that's the right approach.
Okay.
But we're pathfinding here.
Mhm.
It's not a lot of no, there's definitely not much that has been written on this topic. Certainly not in the ICT industry. Maybe in some other industries, but
Mhm.
and I get it. We can't be the only industry that's has this problem, but it's certainly like magnified. And so I do want to dig into the device utilization one, because I know as far as like reporting standards, I'm trying to figure out how it's obviously an important question for circularity and the self-reporting, but like as far as what we're asking for the greenhouse gas reporting standard, I'm trying to figure out how we can describe it and fit it in.
I think you would have to come up with a device utilization meter, as in to simplify it, right? As in how much life has been consumed of that product, right, until that point, and that is calculated based on time and usage.
So essentially, we are saying that we need to handle different devices differently, because this device, the utilization will be different for all the devices, right? Time is a common concept.
Yes, so you
Right.
could have a
Utilization.
situation, right? You won't want to account for, let's say, a device has been only, just for sake of argument, has been only used 10%, right? And has 90% of its life left, right? And you now enter this into its second life, right? In the circularity, you should have then very significant benefit for the original owner of this device, right? From a embedded carbon footprint perspective, right? Because ultimately you should be able to take off 90% of the original embedded carbon that you booked on, basically on putting this device into operation.
Yeah, that's a good point. So like say for instance, you we'll go to the hard drive example, Stefan. So say your hyperscaler, you use your hard drives for 3 years, and then you send them back to the manufacturer. Okay, now you want to, as a hyperscaler, be like, I don't want to take all the scope 3 from that because I gave it back to you. So how do they decide, okay, can we run a test that says, okay, this thing has maybe it has 3 more years of life left, and we can determine from that they will amortize 50% of the embodied carbon. We'll give you a rebate back to off your books. or something like that. Or maybe it's carbon avoidance or something, right?
Yeah, because that creates an additional incentive also for circularity that can be significant.
Yeah, there's going to be. So essentially, how much life is left could be assessed differently by, the first user who is giving it back, and the, organization that's taking it in.
That's why you need a standard, agreed. There has to be a
Yeah.
standard method to do that, so you don't have the
Mhm.
wild west of carbon accounting.
Yeah, but we have to sort of work with, see, for example, HDDs don't say that, okay, this is the life left. And that's a device thing. That's not just for sustainability, but in general, they do not have a industry method of saying that, oh, okay, after so many years, we will say that HDD has this much life left.
We do. It's just in term. I think what confuses people is that device reliability is not measured in years; it's measured in annual failure rate. So
Right.
it's a probability. It's a statistic, right? So
Yeah. So it's a
I can't say for certain that this drive will last for 5 years, but I can say on average in a population of tens of thousands of drives, we're going to see one failure every 2 million hours.
right, but that probability will be known only after, assessing whatever tens of thousands of drives of that model.
Yeah,
So that
right.
means we are essentially saying it will
where-
be decided. It will
Well,
be decided per model, and both the sides, both the parties have to do their own assessment. And then
right,
also there will be variability between both
Right.
of the assessments.
right. It could be different for each user
Right.
based on their use period.
Yep.
But the device vendors do report, MTBF and AFR.
Yeah.
And typically, I think we found, at least in the drive world, that's fairly accurate. Obviously the device vendor, it's different for us. I'll just use, we have a lot of SSD folks on the call here, so I'll use our SSD as an example. Right, where the annual failure rate of an SSD when you first launch it generally starts out higher than the target, and then as you issue firmware updates to make the drive reliability better over time, it goes under the target. And generally, when the drives are mature in their final firmware phase, after a year of production, at least at Intel, we saw like very, very low failure rates, like extremely low, like half or even lower of what the MTBF or AFR target was, right? So twice the MTBF. But then you have the other thing that Stefan said, which is that's the statistical random reliability. Then you have the actual use, which is you can measure in device endurance and percent use.
And if you look into specifications, even of these drives, there are terabytes written, believe it or not. You have terabytes written, terabytes read. There are, if you dig into the technical details, there are specs for that. In the past, they have not been exhausted, so they weren't really within the warranty life, right? And so, but going forward, you will have limitations on write and read for disk drives as well, right? So there are measures to report life left, and I think actually this measure has another benefit. It's not only for carbon accounting, but this is also to give the circularity second and maybe third owner some indication, right, of what is the remaining value of this product, right? I mean, how do people assess this today? Just hope it works.
Yeah.
Yeah,
So,
I'll go ahead, Shruti.
no, I was going to run through some examples. See, here's the thing. Basically what I'm going into is because, this can have different kind of evaluations and it will have contention.
Mm-hmm.
What is the guidance we are giving? Because then we have to nail down, are we saying that it has to take, of course, time into account and the maybe percentage life based on writes that are done, as well as some weightage given to say failure rate that is predicted for the device, and that is predicted for like maybe the non-NAND portion of the device kind of thing. And then that again depends upon, then the manufacturer should be particularly revealing what's the failure rate of the non-NAND portion of the device. And it should be agreed upon. So there is going to be quite a bit of contention. And then also how much weightage is to be given to that, failure rate kind of thing. Because you could say that, oh, it can take whatever, so many 100 TBW, like so many writes still. So it has 75% life. But then if you think that other components are going to fail, because of that failure rate, then that 75% is sort of useless.
Yeah, no, I
It's
understand
fall
it.
into all of
Yeah, I understand the complexity, Shruti, but let me take us back to in the early days of SSD. Each vendor made their own claims, right, of what the product would do, how long it would live, and all of that, right? Then the industry said, well, this is not really going to work. We need to have something that makes this comparable, right? Then the JEDEC JC64.8 standard was work effort was kicked off. And there we had exactly the same problem, right? That people said, well, it depends on how the device is used and all the conditions, right? So then there were two key workloads as a reference were built, and those were basically used to determine what the endurance life was left on the product, right? I don't think we need to engineer or solve the solution within this effort here, but I think what we need to say is that there needs to be a life measure for the product in order to have it be incentivizing to use it for circularity and to allow for the appropriate carbon, and especially embedded carbon accounting. That's all what I'm saying. I understand this is not easy, right? And but I want to use the example of SSD endurance, right? To highlight that there is a possibility to get a index measure, and I totally first to say it will never be perfect because of all the complexities that you described.
Okay, so either we through this try to give a guidance that the work stream working on these individual products, like the ones working on storage and working on processors, etc. All these specs need to start having a way to measure their life. Because because essentially, they are individually working on these
Yes.
devices. And we are saying that if these devices have a way to measure the life, then we are easily able to utilize that in this circularity
Yes.
and carbon accounting.
Exactly. And it also has the benefit, again, not only for carbon accounting, but it will incentivize and it will further promote the circularity, right? Because if you say this product has, after X years of use, 50% of its life left, right? You have a tangible measure of value.
So how will that guidance get picked up? Because that's quite a large item. Are we saying till then we cannot do anything about carbon accounting in circularity?
No, we can use proxies until then. I mean, that's that would be something that you could do as a first order of approximation until you have a dynamic measure to determine life.
Yeah, this is a sticky one, but I think there's, the other thing we were discussing, which is just, okay, you do a life cycle assessment and you decide with in that life cycle assessment, you decide, okay, the old boundary condition used to be 5 years. And you're just saying, let's in that life cycle assessment, let whoever's doing that assessment decide what the average use period is, right? And maybe we decide it's 7 years, 8 years. Just, I think we have some data that suggests, even though that some of these devices like CPUs and stuff will run for 15 years, at some point they just become so technically obsolete that they're not worth running. Like, I deal a lot in the with ITAD folks that are selling like secondary market stuff, and these like 14 core Broadwells that were state of the art in 2011, 2012, 14 cores are now selling for $4 or $5 a CPU. And because even though they're actually pretty good, 100, but they take 125 watts or 100 watts, and you can get a CPU that has 128 cores for that same power envelope, right? So at some point, right? And so I think you just do that I think we just say in the life cycle assessment, this is when you decide, whoever's doing the life cycle assessment, that here's the average, here's what period we're going to use, and here's how we came up with that.
Yeah, and by the way, today, when you look at an SSD spec, right, they'll tell you it's X years or Y terabytes written, right? Like as a proxy. And what you're basically doing with circularity, you're saying like, I'm going to go and extend this, right?
So one thing in the current LCA assessments, that period of use is impacting the operational carbon part, essentially. Right? It's not, it does not impact the embodied carbon part.
You're correct
So,
that it doesn't, the embodied carbon is incurred at time of manufacturing, right? But
right.
if you allocate it over the useful life of the product, right, which I thought that's what the attempt was, then the stretching the operational life would
Right. So
right
what I'm
scale.
saying is, when folks are currently conducting LCAs, like for example, a certain portion of the value chain have more knowledge of the embodied part and they have less knowledge of the use phase. So it is sort of assumed that an LCA report from somebody like that will have a lot more accuracy in the embodied part, but the operational part has some guesses and is less accurate already. But so what I'm trying to hint is that they are not, I don't think they are picking the use phase thinking of, oh, it is going to reduce the accuracy on the embodied side because now we will start using that same use phase as a denominator over here to spread out the carbon, embodied carbon. Currently that's, I think, how it is. Like the general idea is that, okay, embodied part has quite a bit of accuracy when coming from, one of the supplier kind of companies, and the operational probably doesn't. So whatever period they pick, we are sort of saying that you have to pick a more knowledgeable period because now it will affect the embodied carbon spread out also. Just trying to see, these are sort of building, these are quite a bit of dependencies on other folks doing the work properly. So how can
Well,
we,
let me
provide them a way?
Yeah, but let me ask you a question. So, Jim, how do you decide? You take an SSD today. How do you make a determination? How long can this live in a secondary market? In the circularity, how do you make that determination?
No, that is an outstanding question, right? Like, because we look at,
Yeah.
You look at how many writes are done, but you are aware that there are other components that can fail also. That is actually an
True.
outstanding question. That's what I'm saying, that we are sort of depending upon things that we know are not completely resolved. And SSD is actually easier. Other components are even harder.
Yes.
I worked on this one in 2012.
Yes.
P3700. We launched it in 2014, so 10 years ago. Look at this. People are still buying 800 gig drive, $89.
Yeah.
I mean,
Pre-owned.
these things don't die.
No, I understand. I'm just saying that my recommendation is, however, in circularity, right? However, the new useful life is determined today. Someone is making a determination today, right?
Right. Yeah, I see
You
what
can
you're
use
saying.
it as a proxy.
But I would just say, like, to know the embodied carbon, we have to do the life cycle assessment anyways. So just just today, all the manufacturers just say we have a 5-year warranty. That's all we do, and that's all you're gonna get. I think in the future we say that we have a 5-year warranty, but we expect the use period to be X, 10 years.
Yeah.
Right. And it could be, you could even say, I think the proper way to list it is, probability that it gets to, with the caveat of like, obviously, if you use all the endurance before this, then that's obviously, in a use case that's not typical, then this would not apply. But, probability that it would be, alive for 6 years, 98%. Probability that it'll be alive for 7 years, 80%. Probability that it'd be alive for 8 years, and you get down to like, okay, at 10 years, you're at a 30% or 40% probability, right? Where, you see what I'm saying? It goes down every year, right? And that you can build this graph based on, reliability stats like AFR and stuff.
So like in the case of say CPU or GPU, whatever, we are expecting that they have a reliability graph or yearly reliability graph that starts getting provided as a part of spec.
Yeah, these guys, we know, like we I was a product manager for things that sold tens of millions of units, and we had all that data. We had, Intel had quality and reliability people. You run these RDTs, reliability demonstration tests, to figure out like the useful, the annual failure rate and everything. Like, these device vendors know exactly, and they monitor them through 5 years after they sell them, right? Like, these guys, the manufacturers, they know all this data. They have all their quality and reliability guys know this stuff. Like,
Yeah.
I always laugh when I see these like, oh, Backblaze hard drive study. It's like, the vendors know exactly how much their drives fail, because they sell millions of units.
Right. So essentially we are saying that needs to be shared as a spec now. Like even in the drives, we are saying the prediction of how much life the hard drive has.
Yeah. I know this data is shared today under NDA. I think we
No. So
a way to up-level it,
So are you talking about like an AFR, like a failure rate? That is what would be taken as the life left?
Yeah, the other way to do it too would be, really cool is if one of the device manufacturers could do this for a product that they have that's 5 years old, like buy a bunch of used drives and then run an RDT, and then you would know, okay, for drives that are 5 years old or 8 years old, what's the actual new failure rate? And maybe it's the same, maybe it's lower, maybe it's the same, maybe it's higher, right? But that would be probably asking too much. What I'm saying is that what the manufacturers have today for sure is these AFR curves for their products, and they know, hey, we've shipped X amount of devices. We claim our spec sheet reliability is this, our measured reliability is that.
Right, but you're calling the AFR rate that they publish, or whatever, the failure rate that they publish, as that reliability spec that is being shared already. Is that right?
It's being shared to like NDA customers, like nobody.
Yes. With their user.
Yeah. So, but right, I think that also benefits SSD companies and component companies that are making reliable parts. They can say, look, this thing's, statistically going to last for much longer than the 5-year warranty. And so, yeah, there should definitely be a second, we know, like GPUs, there's a huge secondary market for GPUs that like the NVIDIA 3 series, those are still like hugely valuable, and they launched, I think, almost 5 years ago, right? It's yeah, so we, like, empirically we know this to be true, that used devices have some sort of value, and there's secondary market determines that. But the problem we're solving is, how do we figure out, like, we want what is the useful life period of drive or device or whatever, and I don't think any Q&R guy will say, oh yeah, we can just say 7 years instead of 5 now. They're going to say, no, we did our study on a 5-year assumption with the AFR, but I think they would be okay with saying, here's our reliability, you guys figure out how many useful years you can get out of it based off that,
And I want to go back to the question, when you say here's our reliability, you're talking about failure rate spec that is shared. So because there are two things you can look at, even if we think of drives, you can look at how much, workload has gone into it, and you can look at the failure rate of other components if it's shared separately. Even for any other kind of device, there could be a component failure rate, but that's what you're saying, we should pin the life left on.
right? Yeah, is that today nobody wants to go beyond a 5-year life cycle in an LCA, right? But I think that, right, like just even look at like let's see, let's see if I can find an example. Here's like the so when they do this per year, use phase, resources, carbon per terabyte per year, I believe when you look at the LCA, it's just a 5-year life cycle, right? So I think the question we're asking is, Seagate uses the EcoInvent 3.8 life cycle invent. Oh, okay. Yeah, I think they just use this. Estimated operating life, 5 years. So I think you just have to say, okay, when you're doing a life cycle assessment, what are the boundary conditions? We don't want to leave it up to people to interpret reliability. So maybe it's as simple as we push everybody from a 5-year life cycle to a 7 or 8-year life cycle. Just say we know for a fact that ICT components last longer than 5 years. Why are we all saying they last 5 years? That's stupid. If we do a longer life cycle, then we can now say, okay, the embodied carbon per year is decreased, and now you can figure out, okay, if you sell the device after 3 years or 4 years, now your average embodied carbon should be half of what you're what you usually take for a scope 3, and I think that would solve what the hyperscaler is looking for, which is a way to reduce their scope 3.
Who are you saying are all assuming 5 years? Because I know in a lot of places it's not assumed to be 5 years. Are you saying all the manufacturers assume to be 5 years? And
So they have 5-year warranty.
Yeah.
Yeah.
right. So
And so I think you just saw, like I just showed you with Seagate, they just do all their life cycle assessments at 5 years, right?
so you're saying all the manufacturers assume 5 years?
Yep. For sure.
For warranty,
Okay.
yeah.
And that is, see, because for warranty also they do a similar kind of, how much life is left assessment.
Mm-hmm.
So
Exactly.
then what is different? Should you just pin the life left to how much warranty the manufacturer has
I said that's the warranty and the life cycle today are the same. We're saying we have a hypothesis that they're not the same. That in fact drives can last longer than the warranty.
Okay, so here's the thing. In this warranty assessment also, they probably assume how much workload is happening, say, per year, which is an assumption, which on their side they will not know the exact thing, but they must be also incorporating some failure of other components, which will be more accurate on their side. Now the same assessment, if on the user side they will know more accurately how much writes were written per year, but they will not know what is the probability of the other components failing. So I still feel like they are going to come up with, probably different lifespan assessments, and how do we get them to say that follow this to be so that you are on the same page?
But
We can
Shruti,
also,
sorry, but Shruti, when you say other components, for example, I can only speak for an SSD because that's the market I'm in, but overall, the warranty is decided based on everything, right? When an SSD fails, it's not necessarily the NAND failure. It can be a component failure too. So
Yeah.
the warranty covers the entire drive. So isn't that, it's accounted for, right? The components are accounted for. And that is why they are safely saying, hey, our device, we'll warranty it for 5 years. But definitely components can last longer. And don't you think that same would apply to other like a graphics card or a CPU and all those things? I mean,
Yeah. So
feel
just
free to disagree with me, Jam and Stefan, but don't you think we are accounting the components also, right? I mean, we're not just coming up with a 5-year number, just only for a specific component. It's everything included. There's a 5-year warranty.
yeah, I exactly what I'm also trying to say. Like when they are giving us 5-year warranty, they are making an assumption on how much writes per year is happening, but they know more accurately the component failure part. And that net of that is actually life. If both these components, both these portions are accurately put in the, whatever math, then that is probably the right life.
So back to do an amortization, we need to know the number of years. To restate, the problem is that no reliability guy will ever tell you the amount of years because you can't. It's a probability.
Sure.
Right. So you just have to make up a new standard that just says, okay, well, we know that it's somewhere between 5 and 10, and maybe we solicit an OCP study here, which is like, okay, what is the average, the average use period of a drive? What's the average use period of, I know for a fact that memory lasts 10 years. Again, same thing. You just go to eBay and look at DDR3. It's flooded with DDR3 on eBay. These things don't die. They just keep going. So it would be cool maybe to solicit some kind of study like this, but at some point we just need to say, okay, let's pick a number, and we know it's greater than 5, maybe it's 8, and we know that one user wants to use it for a certain amount of time and the second user wants to use it for a certain other amount of time. Let's just, whatever we pick in the life cycle step and whatever number of years the vendor decides to pick, now they can amortize the embodied carbon over that amount of years instead of today. It's just amortized over the first user, even if the first user, right? So if a hyperscaler bought a bunch of SSDs, used them for 1 year, and then decided to shred them all or sell them, they still have to take all the scope 3 and all the embodied carbon from the manufacturing upfront.
Yeah. If you destroyed the life left at the end, whatever life was left, then you take the entire hit. That I think makes sense. That would not have I can't see a contention point where folks would disagree on that.
Mm-hmm.
Yeah, we can pick a number of years and go by that.
Cool. All right. Well, we are out of time. Let me send out those notes and the draft of the white paper, and you guys can leave some comments. I know, Shruti, sorry, I'll remind people next time so we get from the larger mailing list, we get more humans in the call, but I think we have some good direction. So
Yeah, we'll do a shout out. Well, but we can do a shout out next main meeting. So every now and then we should do that for every Workstream.
sounds great. Thanks all. Talk soon.
Okay, thank you.
Take care.
Bye.